Hello student, now here I have taken this example. So first example is determine the stability of the system with this closed loop transfer function. So our transfer function is this Cs by Rs equal to 10 divided by S6 s to the power 6 plus 2s5 plus 2s to the power 4 3s cube plus 5s square plus 6s plus 1. Okay, now see the solution. So from this transfer function we can write the characteristics equation is this s to the power 6 plus s2s to the power 5 plus 2s to the power 4 plus 3s cube plus 5s square plus 6s plus 1 equal to 0. So first step is generating Routh array. So here I have identified what are the first row coefficients and what are the second row coefficient. Okay, so see, now form first row and second row by selecting alternate coefficient. Okay, so in previous lecture I have mentioned what are the first row coefficient and what are the second row coefficient. Okay, so first row form first row and second row by selecting alternate coefficient. Okay, now form remaining rows using the method, that means how we calculate b1 b3 b5 all this. Okay, so see for how we form the remaining rows. Okay, so see the calculation. Okay, now see the interpretation. So see, for the given system to be stable, all the elements in the first column of the Routh array must be positive. But in the above problem, the negative sign appears in the first column. Okay, so negative sign appears in the first column, but in the above this problem, the negative sign appears in the first column. Therefore, the system is unstable. The number of sign changes are 2. Where number of sign changes? From s to the power 4 to s to the power 3. Okay, so see here in s to the power 4, this is s to the power 4 means this coefficient, that is -5, and s to the power 4 is 0.5 and s to the power 3 is -5. That means there is sign changes. Okay, so see, in this problem the negative sign appears in the first column, therefore the system is unstable. The number of sign changes are 2. From s to the power 4 to s to the power 3, one sign change, then from s to the power 3 to s square another sign change, and thus two roots lie in the right half plane. Okay, so here sign changes occur from s to the power 4 to s to the power 3, that means from here to here and from here to here. Okay, s to the power 3 to s square. So there are 2 times sign changes, that means two roots lie in the right half plane. That's why this system is unstable. Okay, now see Routh special case of Routh-Hurwitz criteria. So I have already discussed these difficulties. Okay, so first difficulties is if the Routh array sometimes may have a 0 in the first column of a row, and second difficulty is the Routh array sometimes may have all zeros in an entire row. That means if this condition is coming, then how we will analyze stability by Routh criteria. Okay, so case 1, that means 0 in the first column. So when the first column of a row is 0, okay, since division by 0 will occur to form the next row, then we simply replace the 0 with a very small positive number epsilon. The value epsilon is then allowed to approach 0. then we have to examine the sign of the entries in the first column. Okay, so if 0 in the first column, then how we will analyze stability by using Routh criteria? So the first element of a row, if the first element of a row is 0, then we simply replace the 0 with a very small positive number epsilon. The value epsilon is then allowed to approach 0. Then we have to examine the sign of the entries in the first column. Okay, now we take an example. So see the example. Okay, so here the stability, here we analyze the stability of this system, whose characteristics equation is this. That means s to the power 5 plus 2s to 2 s to the power 4 plus 3 s cube plus 6 s square plus 5s plus 3 equal to 0. So see the solution. So from this characteristics equation, from the Routh array. So here I have mentioned what are the first row coefficient and what are the second row coefficient. Okay. After finding the coefficient of first row and second row, from first row and second row, then we make the remaining row. Okay, in this way. So see in the third row, in the third row, first column element is 0. Therefore, replace it by a small number epsilon and proceed. Okay, so see in the third row, first column element is 0. Therefore, we replace this 0 by a small number epsilon and proceed. Okay. Now see here we replace this 0 by epsilon. Okay, and again form the Routh array. Okay, so see after forming the Routh array by replacing 0 by epsilon. Okay, see the first element in the fourth row is 6 into epsilon minus 7 divided by epsilon. When epsilon tends to 0, the sign of the element is negative. Now see the first element in fifth row is 42 into epsilon minus 49 minus 6 into epsilon square divided by 12 into epsilon minus 14. So when epsilon tends to 0, the limiting value is 49 by 14, which is positive. Okay. So see from the Routh array, from this Routh array, then see the table. Now see from the Routh array, we can observe that there are two sign changes in the first column. Therefore, the system is unstable with two poles in the right half plane. Okay. Now you understand how we will analyze if the first column is 0 in the Routh array. How we will analyze the stability if first column in the Routh array is 0. That means if 0 is come in the first column of the Routh array. Okay. Now come to the second case. Second case is when all the elements in one row of Routh array are 0. So see, when all the elements in a row are 0, first we have to return to the row immediately above the row in which it occurs and form an auxiliary polynomial using entries in that row as coefficient. In the example shown here, the coefficient of the previous row are 1, 2 and 4. Okay. So this row, so select this row and form auxiliary equation. So select this row and form auxiliary equation. Okay, so which row we select for auxiliary equation? See, so when all the elements in a row are 0, first we have to return to the row immediately above the row in which it occurs and form an auxiliary polynomial using entries in that row as coefficient. So here I have taken an example. So in this example, see, the coefficient of the previous row are 1, 2 and 4. 0 row is this, 0 row is this, 0 row is this. So above row is this. So coefficient are above 0 rows are 1, 2 and 4. So here we form auxiliary equation with these rows. Okay, so our auxiliary equation is this: as equal to s to the power 4 plus 2s square plus 4. Okay, now once the auxiliary equation is found, differentiate this auxiliary equation with respect to s and replace the rows of zeros by the coefficient of DAS ds. Then the Raoult array is constructed for the remaining rows in the usual manner and test for sign changes in the first column. So in our example, auxiliary equation is this: as equal to s to the power 4 plus 2s square plus 4. So we differentiate this equation with respect to s. So if we differentiate this equation with respect to s, then this is DAS ds and this is equal to 4s cube plus 4s plus 0. For convenience, the coefficient are divided by 4 to get s cube plus s plus 0. The coefficient are 1, 1 and 0. Now replace the row of 0 by this coefficient. Okay, here I have given how we will replace 0 rows by this coefficient. Okay, now in this case the auxiliary equation is an even polynomial. An even polynomial is one in which the exponent of s are even integers or 0 only. Even polynomial have roots that are symmetrical about the origin. The symmetry occur under several conditions. Either first is the roots are symmetrical and real, or second case is the roots are symmetrical and imaginary, and third is the roots are quadrantal. Okay, here I have given the figure also. So first is the roots are symmetrical and real. Okay, this is the first figure. Second figure, in second figure the roots are symmetrical and imaginary, and third figure the roots are quadrantal. Okay, thus the row of zeros in a Raoult array indicate the existence of an even polynomial whose roots are symmetric about the origin. Once auxiliary equation is obtained, it can be factored algebraically to get the roots. When a row of zeros appears in Raoult array, then the characteristics equation is analyzed using the following step. So first step is find the auxiliary equation s equal to 0 and using the coefficient from the row just above the row of zeros. Second step is differentiate the auxiliary equation with respect to s to get DAS ds. Third step is replace the row of zeros with the coefficient of DAS ds. Fourth step is continue the construction of array in the usual manner for the remaining rows. Fifth step is interpret the sign changes, if any is there, in the first column of Raoult array. And last step is obtain the roots of the auxiliary equation. If they are on the imaginary axis and no other sign changes in other rows, then the system is limitedly stable. If the roots of auxiliary polynomial has roots on the right hand side, then the system is unstable. Since the roots of auxiliary polynomial is roots of characteristics equation. Okay. Now here I have taken one example based on this case. Okay. So this we have considered this example. So here we check the stability of this characteristics equation. That means s cube plus 5s square plus 6s and plus 30 equal to 0. So from this equation first we make Raoult array. Okay. So see in this array which row are 0 row. Okay. S to the power 1 row is 0 row. Okay. That means third row. So select the s square row which is above the row in which all elements are 0 and form the auxiliary equation. Okay. So auxiliary equation of this characteristics equation is 5s square s equal to 5s square plus 30 equal to 0. Now we differentiate this auxiliary equation with respect to s. So after differentiate, this equation is 10s plus 0. Now the coefficient are 10 and 0. Okay. Now replace the row of 0 by the coefficient of ds and continue to construct the remaining rows of Raoult array. Okay. So we form the Raoult array by replacing 0 row by the coefficient of differentiation of auxiliary equation. Okay. Now see all the column elements carry the same sign and the auxiliary equation has roots on the j omega axis. So the system is limitedly stable. Okay. I will also given some example in PDF file based on Raoult stability criteria. Thank you.